So, good afternoon, everyone. So, we will start today's class within a few minutes. So, we will wait 1 2 minutes to see whether others are joining or not, and after that, we will start our today's live interactive session. Okay. So, I am sharing the screen for you. So, I think the screen is visible to you, right? Okay. So, we will start our class. So, this is our seventh live interacting session and on fluid mechanics. So previously we have discussed on this basic concept of fluid kinematics, fluid dynamics, fluid statics and all these things. So before going into today's live interacting session, let me introduce myself. So I am Niloy and I am from IIT Bhubaneswar, a PhD scholar, and I am UTA for this course. So basically this course is under the instructor of Professor Subhashi Datta from IIT Guwahati. Okay, so if you are facing any issue or if you are not able to watch this PPT or you are not hearing my voice, so please raise your concern through this chat box or you can directly on your mic and mention this thing. Okay, so before starting into this today's live interacting session, let me brief about this course. So this fluid mechanics is an interdisciplinary course, and you know that this course is quite vital for the student in civil engineering, mechanical engineering, chemical engineering, and even some other engineering field. So in these courses, we will basically deal with how we will solve problem, real life problem with this concept of fluid. And let me recap about this last class. In the last class, we have discussed about this Lagrangian and Eulerian description and approach. So, and also we have discussed about the motion and deformation of the fluid element. We have discussed about various types of flow, right? And also the potential flow and all these things we have discussed in the last session. So coming to this today's session, so this today's session is quite vital because in this session we will deal with this dimensional analysis. So which is quite important because let me give you a hint for this. Say you are planning to make a aeroplane. So initially what you need to do, you need to make a small design. So this small design you have to check whether it is able to sustain this condition, certain condition or not, and after finding that this small model is able to sustain this condition, so you have to make this model on a larger scale. So that conversion is basically based on this principle of dimensional analysis, and these things we will get to learn from this week's life interacting session. So we will deal with some problems on this session, so which is basically on this dimensional homogeneity and also on this analysis and similarity, and where and how to use this approach. So that is the main fundamental of this today's live interacting session. So before starting today's live interacting session, what I will do is that I will give you a question, say for a question, and I will ask you to solve in 1 minute, and after that I will elaborate this concept and also the solution in details. So I hope that all of you have gone through the course or the weekly course given by Professor Shubhashish Datto, and if you have gone through this course, you will be able to answer this question. And if you are not able, no need to worry because I am here to solve these queries for you. Okay, so this is the first question. So in this first question, it is asked that which of the following is not a primary dimension. So this velocity, time, length, temperature and mass, these 5 points are given. So you have to answer which one will be the answer. So please try to answer. I am giving you 1 minute time. And after that, I will explain the concept. If you are not able to answer, no need to worry because I will solve this one for you. So just try from your fundamental understanding, and also I think this dimensional analysis you have studied in class 11 on this first chapter, right? So this the fundamental of this thing comes from there. Okay. So please try to answer in this chat box. Okay. So Mr. Pandit has answered velocity as the correct answer. Okay, let's see whether it is correct or not. So, Vedisha, you want to try, or I will solve this one? Okay, let me solve this one for you. So, first, I am giving you this fundamental. So, basically, the primary say in this dimensional analysis, you need to know that what are the primary dimensions. So, for this primary dimension, so I am writing the about this primary dimension. Okay, so this in this primary dimension, initially what comes? This comes the mass. So mass we represent as m. Okay. Next is length. So you know length is represent as L, right? And third is time. So time is represented by T. So another parameter is temperature. Okay, so this temperature is represented by basically theta. Next is electric current, which is I. So these are standard representation. Always remember this thing. So next is amount of substance. So this is represented by capital N. And another last one is the luminous intensity. So these are the seven fundamental or the primary dimension that is used, and always remember, so why these are the primary dimension, because these dimension are not dependent on other quantities, so they are self dependent, like mass is itself self dependent. So if I talk about, say, any term, momentum, say if I talk about momentum, what you know, momentum is mass into velocity, right? So that means this momentum is dependent on mass and velocity. That means on two primary dimensions. So it is known as secondary dimension. Whereas these sevens do not depend on others, right? So if I, from this it is clear that mass, it will not be the answer, because mass is a primary dimension. Temperature is also a primary dimension. Time is also a primary dimension. Length is also a primary dimension. So velocity will be the answer. So what exactly this velocity is? Velocity means distance by time. So this distance means length, L by T. So I can write L T to the power minus 1, right? So that's why option A is the correct option. I think you will be able to understand this thing. Okay. So that is the way how you need to solve this one. So this is basically, if the velocity, say somewhere, if the velocity is represented by you, so if someone asks to find its dimension, you have to find like this way. So dimension of u is L by T, which is L to the power minus 1. So I think it is clear. So these are the seven primary dimension, because this dimension is required in this next slides, because once you will go through this lecture, you will be able to solve this question using this fundamental. So mass, length and time, these three you will find most often in this numerical question, and the rest four are not that much frequently used. Okay, so I am moving to this next question. So this next question is that which similarity condition is related to force scale equivalence? So these are the four options. First is the geometric, kinematic, dynamic, and last is the kinematic and dynamic. So I am giving you few minutes time to solve this one. So please try. After that I will explain the concept for you. So see, if you find that this concept is not clear to you, let me know. So Devbrat has answered option A, that is geometry. So let us see whether this is the correct answer or not. So see, I am going through this concept. What exactly is similarity indicates? So the first is this geometric similarity, right? So this uh, geometric similarity, if I talk about, what exactly it means. So this means that here the shapes are scale. Like if there is this is the length. This is a small body. If it is of L length, it is say L by 2 length, like that. So a scale is there. That means if it is 1, it is 2, 1 is to 2. So this 1 is to 2 ratio must be maintained for this larger domain, or the object which you have to prepare. So that is the geometric similarity. So this next is the kinematic similarity. So in this kinematic similarity, basically these motions we kept same. So motion we kept same means this velocity we kept same. The velocity profile, not exactly velocity. That means say if I take acceleration, say this is a particle, right? If a particle is experience some force or this in a domain, so it has some velocities and acceleration. So this velocity and acceleration must be proportional if the system is getting enlarged. So that is the principle of this kinematic similarity, that in the previous one only the length and these types of dimension is getting the symmetric features, whereas in the kinematic we have to deal with velocity, acceleration, like this. It is basically based on length. Not exactly length, but I am for your understanding I am giving you this example. It is basically on velocity and acceleration. Third is dynamic. Next is dynamic similarity. So in this dynamic similarity, we have to deal with the force. So what we need to scale? We need to scale the force. So the force is scaled the same way in the model and the prototype. Okay, what is the model you need to design and what are the prototype you are working on? That both things should have the force. Say if in a model X amount of force is applied, then in the prototype it should be n into x. So a percentage error should be there, percentage or a number should be there. So that is the thing. Say I am giving you an example. So in this dynamic here, we are taking this ratio of the forces. Like if you talk about this Reynolds number, okay. So what Reynolds number or fraud number? So that thing we have considered. So that types of thing, Euler number, surface tension for these all these thing non-dimensional number are used here. Okay. So and that's why the correct option is in the question similarity related to force. So in the force I have said that dynamics similarity. It indicates from this dynamic similarity. So is it clear? Okay, I think so. I am moving to this next one. this is another question where it is said that the unsteady, fully developed coherent flow between correct sorry got the flow between two infinitely small plates. The problem involves the following parameter: velocity component u, the distance between the plate h, the vertical distance y, the top of the plate k, fluid density and alpha, and all these things are given. So you are asked to find the number of expected non-dimensional parameter pi s for this problem. So I am giving you 1 minute time to solve this one. Any idea? Any idea? Please tell. So the brother has answered 4. Huh. So it's option B you are saying. Okay. Okay, I am solving this one. Okay, I am solving this one for you. So what is given in this question? So number of parameter, first let me count this number of parameter. So one is velocity, distance, vertical distance, 3, 4, 5, 6, 7, right? So number of parameter n equal to 7. Okay. So among these basic dimension of the primary dimension, what I call, which are the primary dimension? How many primary dimension? Primary dimension. What are the primary dimension? These are mass, length, and time. Okay, so number this is 3 quantity and this is 7. So that means this primary number is, I represent it as j equal to 3. A number of element is 7. So what I will get? I will get the independent dimension p equal to n minus j. So this n is 7, 7 minus 3, 4. So this is 4. So this correct option is 4. So see how you will able to correct, how you are able to check what are the elements are there. So as we have got the answer, so let me clarify this thing for you. So see, so among these, what are the term we have got? So as number of as n by p, n by j, we get as 4. So the 4 groups are expected. What are those the term given are, if I am writing down the term u, h, y, v, rho, t, mu. So these are the thing. So say already we have got the primary dimension. So this pi, as in the question says, the 4 pi should be there. So this 4 pi should be combination of all these thing with v. U by v I can write. So it is a non-dimensional form of velocity. Pi 2 as height is given. So area we need to find. Okay. So I can write this as not h. For your simplification, I am talking it y. Y by h. So this pi 3 is can be written as, sorry, this is mu. So some issue is coming on this board. So these are the 4 terms that can be. So first is a non-dimensional form of velocity. Next is variation height by total height. So it is also non-dimensional form. Next is rho v h by mu. This is exactly this Reynolds number. I can call this as Reynolds number. And this is the velocity into time is distance by height. This is another non-dimensional form of the. This is another value of 5 1 5 2. So there are 4 5 1. So that's why the correct answer is option B 4. Okay. So 4 pi groups should be there. So if you want to formulate among these terms, so basically there are 4 non-dimensional terms which you must need to incorporate into this equation. That is the thing. Okay. So I am moving to the next question. So in this question you are asked to find the primary dimension of kinematic viscosity. Okay. So please try to answer. I'm giving you 1 minute time. Yes, this is answered C. Yes, good that you have. Yes, it's the correct answer. Option C is the correct answer. So let me show you how to solve this one. For this, either you need to know the formula or you need to know the SI unit. Anyone is specific. Say, let us assume I know kinematic viscosity. So what basically is kinematic viscosity? So you need to know the formula, that would be better, because always it is not always you will not able to remember this thing thoroughly. So if I represent this kinematic viscosity as mu, so it should be mu by rho. Rho is density, you know. and mu is dynamic viscosity. Say how I will get mu. So where you find this mu? You remember this formula in this equation or Newton's law of viscosity, mu du by, right? This formula. What is force? Force means mass into acceleration, which is this one, right? Area is this one. So you need to find mu first. This u is and y is L. So I can cancel L. One L is cancelled. So one T is cancelled, right? So what I will get, this mu is M L inverse T to the power minus inverse. So this is how, so remember this formula. This is basically the formula derived from this Newton law of viscosity. So from this we got mu. And density, what is density? We know density is mass by volume. Mass means m, volume means unit is cube. So m L cube, m to the power m into L to the power minus 3. So here I can write in place of here m L to the power minus 1 T to the power minus 1, that is the mu here. M L to the power minus 3. Okay. So that means it will be L to the power L squared T to the power minus 1. So this, that's why this correct option is option C. So I think it is clear to you all. So Berisha, good that you have answered it correctly. So I am moving to this next question. Okay. So please try to answer this question. I am giving you 1 minute time for this one also. And after that I will solve this concept for you. So check if you are able to answer this question. Okay, I am giving you one more minute to check whether you are able to answer. Okay, I am just giving you some hint or some concept which will help you to answer this question. So let me discuss about some non-dimensional number. So this first one is the float number. So please note down this number because it will be quite essential for your study. So say if I represent it FR. So what basically this float number is? So this float number basically represent the ratio of the inertial force to gravity force or a gravitational force. So it's a ratio of two forces. And why it is essential? So it is so in order to know it's essential, first I am going into this formula. Okay. So basically on the conversion you will get this formula where this is V by root GL. So that is the formula which will eventually come out. So I will show you how this will come if in any question it is required. Um, till then you see when to study for this number or when to check whether this number needs to be studied. So say if in any problem or any question it is given that it's a gravity dominant or free surface flow. So gravity dominant free surface flow means I'm writing this thing. Gravity dominant. See, gravity dominant there should be gravity and it is free surface flow. That means it is related to some water, all these things. So if you talk about this example, in this example comes the ship, then spillways, wave problem and all these things comes up now. So see, there should be an water level. In all these cases, oil problem should be there. Should be a free flow, free surface flow in ship also, in seafood also, right? So what in this problem, a model of the reservoir is emptied in 10 minutes. That means it's a free flow condition is given here, and also its model scale is given. So this number is required here. So that is the fraud number. So now I am moving to this Reynolds number. So what is basically this Reynolds number? So fraud number, you remember that is the ratio of the inertial force by gravitational force. And why it is essential? It is essential to characterize whether it's a gravity dominant free surface flow or not. Okay. Reynolds number. So this Reynolds number, say it is represented by Re. It is basically the ratio of this inertial force by viscous force. Okay. So if you will always find this formula, I think so you have seen this formula, rho VL by mu or rho VD by mu. This formula you find. So why this thing is quite essential? Say C is the inertial force by viscous force. That means here viscosity plays a vital role, right? So viscous effect. If viscous effect come, what are the things that you need to study? You have studied. You will study. Right now you haven't studied. I think you will study the concept of boundary layer. So these are some of the concepts that you will study in these upcoming classes. Okay, turbulence and all these things comes through this viscous effect concept. That's why this Reynolds number comes when there is a viscous flow, or when velocity is given, and all these thing is given. In that cases, or say diameter is given, velocity mu is given, or kinematic viscosity nu is given, all these things are given, then you need to go for this Reynolds number. Say in a question it may be given that a prototype is made, a model and a prototype is talking about. In a model, the Reynolds number is this mass, the value of the Reynolds number is given, and corresponding diameter is given. So you are said that the same Reynolds number is being used in the prototype having diameter this much. Say 5 is the initial diameter, and next the diameter moved to 25. So now you are asked to find the velocity. Like that types of question can be asked. So that is the concept of this Reynolds number. Okay. So this two number is clear, I think so. Next is a Mach number. So Mach number is represented by Ma. So it is basically the speed of the flow, any flow, whether water is flowing or air is flowing, normal speed of flow by speed of sound. Okay. So basically, what we know, the speed of flow, say if the speed of flow is v, what is the speed of sound? So you know the speed of sound, but the general formula is gamma RT, right? Root over gamma RT. That is for air I am talking about. So this formula, what I have written is for air, for gases. Okay. So why this thing is necessary? Say if this thing is necessary to check whether this is a compressible flow or not. Or say if you see, sometimes you have heard about this jet flight. So if it is moving, it will create some sound, noise is coming. Why this noise is coming? This is because of this high speed flow. So a noise is generated, that is known as, that is the concept here. So if you find, if in some cases, say this Mach number value you find out, if you found that it is greater than uh, 0, that means it is that means compressibility begins to matter, air is getting compressed. Okay, that is the concept. So when will this Mach number be used? Mach number is used when you hear this word supersonic sound, supersonic testing, or aeronautics, and all these things you will get to know about this thing. Okay, even in aircraft, rocket, high-speed nozzle, and shockwave, this concept of Mach number is used. Okay, now I am moving to this last number, and that is the Wegener number. So this Weber number, so this Weber number is basically this inertial force by surface tension force. So that is the concept. So it is basically the inertial force by surface tension force. And finally, what the equation that you got to study is FL square by sigma. That is the thing. So if the Euler number is small, what that indicate? This indicate that sigma is more. That means surface tension is large. So if the Euler number is large, that means inertia is more. That means surface number is less. So that is the concept of this Euler number, and this concept you will find in ink or say in the printer, so in some of the printer there is option to print depth with the depth ink or light ink, that option is given. So that is basically by controlling this webinar number. If we require more color, then we have to reduce the surface temperature, surface tension, then at that case it is possible. So this is the fundamental concept regarding this phone number. So now I am solving this question for you, right? So in a question, if the surface tension is given, then you need to use the Webiner number. So coming to this question, in this question, a reservoir is emptied in 10 minutes. That means here some of the water is coming and water is flowing. So it's a condition of free flow. So for this free flow, we know we have to study about this Froude number. So that means the Froude condition should be same here. So basically, what is given in this question, it's a model and prototype. So say if I assume this, so the fraud number should be same for both cases, for the prototype and the model, right? Say for the model I represent it M, and for the A I represent it as P. Okay. So say here I can write in place of this one. So I can write Vm by root G L, and G is gravity. Gravity is small in all case, by Vp by rho G Lp. So this Gg is coming. So Vm by Vp, this one Vm by Vp, this one is Lm. Okay, this one is the formula that nutrition. So now they said that modest scale is given. So what is exactly modest scale? Modest scale means they have given Lm by Lp. Modest scale is a model to prototype. So it is 1 by 25 it is given. Okay. So this modest case Lm by Lp is given. So using Lm by Lp we will get Vm by Vp is 1 by 5, right? Okay. So now you have to find the time. So how do you know this time? Time and velocity is linked to time is equal to, so you know this time equal to, right, length distance by velocity or length by velocity. So here I can write, so here what I can say is the velocity, I don't have any idea about this velocity, right, or wrong? Yes, no, I have the velocity. Yes. So Lm by Lp is given. So you need to find Tm by Tp. Accordingly, you can find out, right? So please find out. So this one is Lm by, so you put this value. So if you put this value, you will get Lm by Lp is 1 by 25. and Vp by Vm is 5 by 1. So you will get the answer as 1 by 5. Okay. So this time is 10 minutes is given. So you need to find out TP. So this TP you can find out, right? So this TP means TP is equal to 5 of Tm, which is 50. So that's why this correct answer is option B. Okay. So it's a lengthy concept, but I think that this concept is why I have applied this fraud number. I think you understand this thing, right? So please let me know. Okay, I think so. Can I move to this next one? So I am moving to this. I think Vidish, you understand this thing. If anyone having any concern, please raise your concern, or I'll move to this next one. So see, as I have already discussed this concept in this earlier slide, now I hope that will be able to answer this question. Is the ratio of this inertial force and the surface tension force is generally known as what? So please, please try to answer. Yes, it's correct. Yes, both of you are correct. So that is the in ratio of the inertial force and the surface tension force is known as Wiener number, right? So what is the purpose of using this number? Basically, this number will tell you whether the effect of surface tension is more in a specific purpose for or not. Like I have discussed about this ink, jet ink. So here this concept is quite essential, and based on this concept you can make large printer and all these things, or small printer, because the concept should be same, right? So that is the fundamental here. So I am moving to this next question. I hope that, so the correct option is option D here, and also the formula I have given earlier. So see, one thing, so how this formula is coming here. So basically this is inertia by surface tension force, right? Inertia force means we know this is rho into v square, right? Rho v means mass into v. This is inertial force. So, and the surface tension force is this one. This is surface tension. Okay. So basically, I am writing in terms of stress, not force. So, sorry. Let me correct this thing. This one is not force. This is I am writing in terms of stress. Okay. So in case of if it is force, so what then it will look like? It will look like in case of force WE, say this is the same thing coming from here also. If you take the inertial force, then also the same thing is coming, rho v square into area. So area I write it as L square. Okay, surface tension force is sigma. Sigma is surface tension force into L, right? So and accordingly you will get sigma itself is the surface tension. So surface tension is the force per unit length. So force per unit length into if you if into multiply it into length, you will get the surface tension force. So sigma is surface tension into length is the surface tension force. So that's why this thing is coming. So this is the next question. So you are asked to find the dimension of the pressure gradient in a fluid flow is given by what? So please try to answer. I am giving you 1 minute time. Again, good, Melissa. You answered option D. Hmm. Okay, let us check whether your answer is correct or not. So basically, the term here is this pressure gradient. So what is pressure gradient? So pressure gradient means change in pressure per unit pressure gradient, that is change in pressure per unit length. So if I represent in change in pressure by length, there is also change in length, right? So that means basically if I represent this term, say pressure gradient term as this term non-dimensional form, so you need this dimension of P and below you need the dimension of L, length. So pressure basically is, what is the E of pressure, dimension form of this pressure, force by area, right? So you need to know this E of force by area into L. So force is mass into acceleration, that means m acceleration, that is meter per second square L to the power minus 2. Okay, this one is L square, area is L square, below is L. So one L is cancelled out. So ultimately you will get m L to the power minus 2 T to the power minus 2. So the correct answer is option D. Good, the Videshi have answered it correctly. So it's the correct answer. Okay. So in this way, please follow this approach so you will be able to answer this question quite easily. So I am moving to this next question for you. So this is another question. So here you are also asked to find, just a minute. So a shape of full length and scale is given, right? And its velocity is given. So the for this dynamic similarity, this velocity for this model should be. So initial velocity of the model is given, sorry, initial velocity of the prototype is given. You are asked to find the velocity of the model. So what type of concept is to be implemented here? So that is the concept that I have already explained in some of the in 2 to 3 slide back. So please try to answer. I am giving you 2 minute time. Please try to solve. So I have received an answer. Let's see. I am waiting 1 more minute. So please try. Uh, okay, I will solve this one right now. Please have a look. So see in this question. So what is given? So main basically this prototype, the ship, which is basically this prototype. If I talk about this prototype, the ship here is the prototype, and the model is also given. They talk about a model. So say if I represent model as M and this prototype as P, right? What is given in this question? In this question, the full length is given. That means LP is already given as 100 meter. And also this velocity is given. That is VP is given as 10 meter per second. And anything else is given, and the velocity for a 1 is to 25 model. That means in this question the length scale is given. What is the length scale? The length scale basically this thing is given as 1 by 24. Model is to prototype is being replicated into 20 times, 25 times, right? So that is given in this question. So here it is a dynamic similarity. They are talked about this dynamic similarity. Velocity and length is given. So let me thought about all this number, and so what are the number that may comes into the scenario? This fraud number can comes, and which can number can comes? Either the Wegener number comes, no, because surface tension force is not given, right? Mach number will also will not come. because period of sound is not given. So either Froude number or Reynolds number should be used. As the viscosity is not given, so we do not have any other option. So we have to go with this Froude number, right? So using this Froude number concept, we have to solve this one. So what is given? So we know that in both the cases, this Froude number should be same. Fr of prototype should be Fr of m. So in case of prototype, so I know that Fr this equal to V by GL, right? So if both of these are same, then I can write Vp by G is also same. I can write Lp. This equal to Vm by root Lm, right? So you are asked to find Vm. So Vm basically is Vp into Vm by, okay. Any confusion up to this? Vp equal to Vm. Oh, sorry, it's a mistake. So Vm this equal to Vp into root Lm by Lp. So I can put this value. Lm by Lp is 1 by 25 and Vp is 10. 2. So this is 2. So the correct answer is option A. So by equating the Froude number in both the cases, I will be able to solve the question. Okay. So can I move to the next one? Okay, I am moving to the next one. So in this question, it is another simple question. Which of the following is not a fundamental dimension of the primary dimension? I am giving you 1 minute time to answer this one. In the first slide, I have discussed about all these things. Which will be the answer and what will be its unit? Any idea about this question? So Debrath has answered option D, that is the pressure, right? Yes, that is the correct answer. So, so let me recap what we have studied earlier. So basically these dimensions are, we have talked 7 important dimensions: length, scale, time, temperature, electric, and all these things comes under this fundamental dimension, right? So that's why this question is here. So beside this, there are two things. Current is F written, amount of substance can be written as N, and also the luminous intensity which is J. So these are the fundamental concepts. So only I have found that among these three are the main, and all these things are here. Here mass is given, length is given, time is given, so pressure will be the answer. So if you want to find pressure, right? If you want to find out this pressure, so how pressure is forced by area, right? So accordingly you can find out pressure is forced by area. Force is ml t to the power minus 2 by area L square. ml to the power t to the power minus 1. T to the power minus 2, sorry, not minus 1. So this correct option is option D. So that is the way to answer this one. So I am moving to this next question. Please try. So this is another fundamental concept. So please try to answer. Okay. So I think this question is, you are not familiar with this question. So I am solving this one for you. I think you are not familiar with this concept. So I am elaborating in depth about this thing. So basically, see what are the basic difference among these things. Geometric similarity. So basically, if someone says that geometric similarity is there, that means every dimension of this model is scaled from this prototype by the same constant. Okay. So as I have to say, if I have to, this is our small scale and this is our large scale. If in the small scale the length is so if the length is, say, this is 2, this is 4. So say there should be a factor LR which is known as Froude number. Okay. So what this Froude number do? Sorry, not Froude number. So this is length. I am talking about the length. So this is scale factor. So basically say the scale factor value say 3. That means if it is 2, it should be 2 into 3, that is 6. It should be 4 into 3, 12. So in this way it will work. Okay. So that means here in case of this geometric similar, a length scale is must. So that is the first thing. So for this, the geometric similarity, what we need? We need the similarity of the linear dimension. So if the similarity is changed, and then it is not of no use. So in this way, you say for length. Geometric, remember one thing for geometric case for length, it is TR, for area, it is okay. Area volume should be okay. So these are the three things that you need to remember. So the correct option is the similarity of the linear dimension. It depends on the similarity of the linear dimension. So I'm moving to the next one. Now at least try. So anyone? So from this Vidisha side, it is hmm, good to see that you have answered. So let us check whether it is correct or not. So option B. Okay. So similarly, since this thing is given, it is basically this concept of fraud number. So what is just a minute, anyone? So this fraud number, what is this concept of this fraud number? So let us assume in two cases this fraud number, a model is there, a prototype is there, right? Say model I represent as M, prototype I represent as P. Okay. So this fraud number FR, say this fraud number I know that is V by root 2 GL, right? So in this gravity dominant free surface flow, this is used to know. So I can write using this principle of fraud number of the model and the fraud number of the prototype should be equal. So in that cases I can use Vm by gravity is constant, so I am not writing Gm here. So Lm So Vp by root GLP. So this G will cancel out. So I can write Vm by Vp is root Lm by Lp, right? What is LR? LR basically is the length scale. Just remember, length scale basically means the ratio of the length of model by length of prototype. That is a smaller body by the larger, smaller length by the larger length. So if it is LR, so I can write this as root LR. So this velocity ratio Vr, if Vm by Vr, I can write it as Vr. So Vr is basically Lr to the power half or root Lr, whatever you want. So all these four option has this first thing correct. Now you have to check for Q, right? Say in terms of Q, okay. So velocity I got in terms of Q. We know Q is AV, right? I can write Qm by Qp equal to Am by AP into Vm by Vp, right? So Vm by Vp basically is Vr. So Am by that is area. So I can write in place of area Lm square by Lr square, sorry, Lp square. Similarly here I can write root Lm by Lp, that is to the power 5 or this one. Ultimately you will get this as Lm by Lp, Lm to the power 5 by 2, Lp to the power 5 by 2. So the correct option will be option, which one will be the correct option? Option D is the correct option. Okay, so the correct option here is the option D. So now I think that you understand your mistake, Vidisha. It's a little bit mistake from your side. Most probably in case of area you have taken L. So that is the main mistake. I think so. Okay. So now I am moving to the next one, right? I am moving to this next question. Any confusion up to this? Can I move to this next one? Okay. I am moving to this next question. So this is the question. In this question, geometrically similar spill OA model is constructed to a scale of 1 is to 16. That means LR or LM by LP is given as okay 1 is to 6, corresponding to discharge of 102 cubic meter in the prototype. The discharge in the model in cubic meter metric will be what? So you are asked to find this thing. So this is basically this concept of non-dimensional, as already I have solved a question regarding this. Now you please try, you will be able to answer this question. So please try. So I am giving you 2 minutes time to solve this one. Okay. So both of you have answered option A. Check whether I'm checking whether it is correct or not. So basically, first you need to check which number to be used. In this question, geometrically similar spillway. So as I have said, the spillway concept is on this float number, is based on this float number. So also the scale length is given, and nothing is anything, nothing is not, and any other details is given. No, only the discharge is given, right, in the prototype. So let me write down what is given in the question. So basically in this question, so I am writing it is LR. LR is 1 is to 16. That means LM by LP is 1 by 16. That right? Also in the prototype discharge is given. Yes. So this prototype discharge, as this prototype discharge is given, so what is the formula we know? In the last slide, what we have got? QR is equal to LR to the power 5 by 2. Like that you got. How you got? Q equal to AV. Using this thing, you can find out this one, right? So in place of QR, I can write what is QR. QR means Q model by QP. So see this formula, you will not able to, always you will not remember this thing. So you better go through this concept. That means Q equal to AV or QM by QP equal to AM by AP into M by VP. Accordingly, you find all other terms, right? So similarly here I can write this one. So in this question, what is given? So QP is given, right? This one is QP. QP is 1024. So in I can write QM equal to QP into LR 3 by 2. So QP is 1024 into LR. LR basically is 1 by 16. 1 by 16, this means I can write to t to the power minus 4. Okay. So in LR I can write t to the power minus 4 into 5 by 2. That means this 2 and this 2 will cancel out. That means t to the power 1024 into 1024 means t 2 to the power 10 into 2 to the power minus 10, which indicates 1. So the correct answer here is option A. So similarly in this question, they will ask you to find out this area or any other same parameter they can ask you to find out, right? So you have to use the similar approach. So now I am moving to the next question. Okay, this is another question. Please try to solve. I am giving you another minute, another 2 minutes to solve this one. Please try. So please try to solve this one. So you say option D. Okay. Check whether what Mr. Pandit answer. Okay. Devbrat has answered option D. Then I think that as both of you have answered, then option D will be the correct answer. So let us check. So I choose on everything is correct. So see, first you write down what is given here in this question. So in this question, this scale length, that means LR is given as 1 by 50, right? So you are asked to discharge of the prototype, that means QP is already given as 530. This is similar question like the previous one, right? So you know that QR is proportional to LR to the power 5 by 2, right? So you are asked to LR means this thing. This is equal to, consider this as equal, not so, or I can write Q and this equal to QP into LR to the power 3 by 2. So QP here is 5303 into LR is 1 by 50 to the power 3 by 2. Okay, using the calculator you will get the answer, right? So I am using the calculator here. So you will get answer near about 0.3. Okay, so the correct option here is option D. So it's a similar question like the previous one, and both of you have answered it correctly. They good for this your response. And next, I am moving to the next another question. So this is a here two lists are given. This is based on the fundamental what you have studied till now, and after this we have two more question. I think so. One question here and another two question I will give you. So please try to answer this question. I am giving you 2 minute time to solve this one. C. Okay. Yes, and what about the breath yes, option C. Yes, yes, option C is the correct answer. Okay. C. So I have already explained what Mach number is. Mach number basically is the ratio of the speed of a fluid to the speed of a sound, right? So that means here Mach number is, if it is v by the velocity of sound, I can write. Similarly, next is the Reynolds number. So option A, Mach number, is which one? Velocity of the sound, fluid velocity. So this is your P, right? And next is the Reynolds number. Reynolds number means, what is the purpose of Reynolds number? Basically, it is equivalent to this viscosity, inertia by viscosity, I by viscosity. So inertia by viscosity is which one? This one. So this is Q. Next is Webiner number. This is for surface tension. So we know, therefore it is R, and inertia to gravitational force is Froude number. So basically S is, sorry, P is 2. P is 2 in option A. Q is 3, R is 4, and S is 1. So option C is the correct answer. Okay. So option A is the correct answer. So I am moving to another question. So this here, in this question it is asked that a device is operating on a surface of a liquid. To study using this model with ratio 1:20, what should be the ratio of the kinematic viscosity between the model and the prototype, so that the Froude and the Reynolds number remain the same? So in this question, the approach is that both this spot number and Reynolds number should be same. That means it is I'm talking about this concept of model and prototype. So use this both formula of the Froude number and Reynolds number. You will get this thing. Ratio of kinematic viscosity you need to find out. Okay. So please try. So take 1 2 minute to solve this one. Option C. Okay, let it check. I'm waiting 1 more minute. And after this question, I will give you one more question regarding this, regarding another concept. So till now, what are the concept we have studied? The most of the numerical is from fraud number, and in this question, the concept of this Reynolds number is implemented. So two number is remaining. So the numerical on these two concept is quite less. And in Mach number also there is concept like say in some of the question they will say the Mach number will be providing, and also this speed of the sound will be providing. So you are asked to find the velocity. You can easily find out. So simple numerical is given on this topic of Mach number. So that is a simple thing for you. But the most of this complicated or real life based problem is based on this thing. So please go through this concept of fraud number, NOS number, and webinar number. It will be quite vital for you. And most important is this fraud number, right? So, so I think I have to solve this one for you. Okay. So, what is the first thing is that I have to write down what is given in this one. So, a ratio is given. That means LR is given here, which is 1 by 20, right? Okay. So, fraud number and NOS number remains same. It is already given. So, as the fraud number is same, fraud number of model by fraud number of prototype is same. So, I can write Vm by root GLM equal to Vp by root GLP. So accordingly, I can write Vm by Vp is root Lm by Lp. So that thing already I have, though I know these things, still I have written this thing for your convenient. I can write, right? That is the thing we have got from this equivalency. So now I will take this concept of Reynolds number equivalence. So as the Reynolds number is equal, again I write Reynolds number of M equal to Reynolds number of P. So Reynolds number basically is say RE is rho AL by mu. So in this question, kinematic viscosity is known. We know what is the kinematic viscosity. Kinematic viscosity nu is equal to mu by rho. So here mu and rho is used. So I can write this as rho VL, sorry, not AL. So VL by mu, sorry, VL by, so VL by, I can write it as mu. So accordingly, I can write V of M by L of M by mu of M equal to V of P L of P or mu of P. So I can write mu of M by mu of P. So this means V of M by V of P, L of M by L of P. So this basically means this ratio I can write into V of R into L of R, right? So this V of R is L of R to the power zero point 0.5. That means L of R to the power 1.5, right? So that's why the correct option is option C. So option C is your correct option, right? So I think you understand this concept. Okay. So I am giving you another question. So a question here I am giving you a question. So please try to solve this one. And this one will be the last question for today. Okay. Say this question I am writing here for you. Say for a water drop, for a water droplet 2 mm diameter. So a water droplet is given whose diameter is 200 mm with density. Rho is density here. Okay. So the density is given as kg meter cube and surface tension. So surface tension, let us consider it is sigma. Sigma is 0.072 Newton per meter. So density diameter sigma is given. So you are asked to find, compute the Weber number when the droplet moves with first is 10 meter per second. So you just, the question is this one. So at 2 velocity, if the droplet moves, so you are asked to find the Webinar number. So please just write down your answer in the chat box. So I am giving you 2 to 3 minutes. So please try to solve this one. So please try to solve. If you are facing any issue up to this, you can raise your concern to me. So this is one question. So just for your hint and purpose, this is basically just using this formula you can solve. Rho v square by L into sigma, right? So that is a fundamental question. So I think using put this value you can easily find out this thing, right? So no need to waste time on this one. So as this velocity in the first question, velocity is given as 10 meter per second. So if you put all this value, you will get WE is as around 27778 like that. And if V is 1, you will get it as around 28. Okay. So that is a simple question, but the main question here is the what types of question will come from this concept. Okay, so I think up to this it is clear. So I am giving you an example. Okay, so which will help you to understand this more precisely. Okay, this one. So I am giving you an example. Say in a question, say certain types of question can be asked. Say we have a spherical droplet, right? Droplet generator. So its main purpose is to generate a water droplet. Droplet is designed to eject water droplet of diameter 2 mm at a velocity of 3 meter per second to study its behavior. A similar model is built at 1:10 scale. So that is given. Okay. So question is that find velocity at which the model droplet must be ejected. Ejected. So you understand the question? So in this question, so what basically is given? So I am showing you this. So how to solve this one? Basically here the main thing is that in some of the question it will be given that the Euler number is equal, but here no such information is given. But see, as droplet, as it talks about this droplet and jet, we got to know that is the concept of Euler number. But in most of the question in the last it will mention that keeping this Euler number constant. Okay, so that thing will be mentioned. If it is not mentioned, still you can consider. Model is, I can write like that, right? Assume, I am just assuming this thing. So in place where I can write rho Vm square Lm square, sorry, Lm by sigma. So as the liquid is same, so rho and sigma will not be changed. Only the velocity and length will change, right? So I can write Vm by Vp square Lp by Lm. What is given in the question? In this question, the Lr is given as 1 is to 10. That means Lm by Lp is 1 by 10, right? So I can write here 10. Okay, so we are asked to find model. So Vm is Vp to the power root 10. So already we know Vp is given as 3 meter per second. So this is 3 root 10. So accordingly, if you find out, it will be 9.49 meter per second. In this ways, these types of problems are is to be solved. So any confusion up to this, Devabraj Vidisha, anything, please let me know. Please let me know. Okay, thank you, Devabraj, for your response. So see, as it is our seventh live interacting session, if you have missed the previous session or you have doubt regarding this, you can have this video, and this link has been shared with you from this NPTEL site, right? Also in these classes or in the previous classes, if you are facing any concern, you can contact me through my mail ID. Okay. So also in the feedback form, you mention all these things, how you like these classes and what are the things you feel need to be improved. Okay. So up to this, any confusion? If no confusion, then we will wind up today's live interacting session. Okay. Then I will. Okay. Then I will close today's session. So thank you for joining this session. So have a good day.